Okay, now we are in the part 2 where I want to model the beam itself by using MECWAY. Okay, so as usual we will create our required nodes, which is from 0, 0, 0, the first node coordinates, and I want to use this tool relative to previous where my second node will be 10 meter from the first node, so you may see that will be there somewhere there, and the height of the beam order that will be is 1. So when we click add, you can see that it is created there, and I want to create the final distance which is measured from this third node, which is 10 meter in the negative x direction. So I will click that, and you may see that the fourth point there. Okay, so we'll see that in our plane, and I will use the quad 4 to connect all together, and I'm using the clockwise, the anti-clockwise direction, or you can use also the clockwise direction. Okay, so as usual I will select this element, and then I will mesh it into, let's say this will be, let's say, to be 10 and my s to be 2. So okay, it's not right because should be, this is should be 2 and this one to be 10, so I can undo, so do it again. So refine custom, so this will be 2 and this is to be 10, so to be something like this, and so to start with the analysis, I will define the material properties of this. So the thickness is 1 meter. You still remember that the height is 1 meter and the width is 1 meter, so this is 1 meter, and this is the material properties, which is 200 gigapascal, and the density is 7,800. Okay, so now I want to define this to be a fix, so I will select that nodes, and I will select this face and choose it to be a fixed support. Okay, and to define the self weight, so you can click on this button, load and constraint, right click, new gravity, and that gravity will be in the y direction, in the downwards direction, so that will be negative 9.81. so click that OK, and I want to assign that 10 Newton to be here, so I will activate the nodes, select that points, and put the new force that will be in y, and this is in kilonewton, so that will be 10. Okay, so the rest just choose it to be static 3D, and this is internal, no need to click on the CCX, and I will save, I will run this. So okay, seems to be okay, and look at on our y direction, displacement, and you may see that the maximum displacement will be on this side, with the blue color, which is 0.003998. and if you still remember our theoretical value, is about 0. If you still remember from the first video, 0.005738885, which is not similar. So why this happened? Because you are using quad 4, so you are using only 4 nodes to represent all of the element. So now to increase the accuracy, I will change this quad 4 to quad 8. So all of this mesh will be converted to quad 8, provided that all of the nodes number is not exceeding 1000, as you know that this is a free version. So I will select the whole thing. Okay, sorry, you have to select the element first and select the whole thing, and click this button, change element shape. So I will change to from quad 4 to quad 8. So click this OK button, and you can see that if I select node, you may see that now we have additional nodes at the midpoint. So to check whether it is okay or not, click on the nodes mesh element list, check whether the nodes number is more than 1000 or not, so it's okay. So now what we will do, we will rerun it again and see the displacement. So now you can see that this displacement is 0.005983, and if you compare with the first part 1 video, the theoretical displacement is 0.00573885, which is almost similar. Almost similar. And if you want to see the deform view, you can click this. This is the deform view. Okay, so that is the validation between the displacement by MECWAY and the displacement by the theoretical, which is almost similar. And if they say I want to see the stress, so you can click this on the von Mises stress, click on the mid plane, okay, and I will change this to be megapascal. You may see that the maximum stress will occur at this part, as we did in our theoretical part, where the theoretical answer will be 22.96 megapascal, whereas in this simulation we have 23.56, which is almost equal. So if you want to get a much more better, so maybe I have to select the whole thing, and maybe you can refine the mesh. So I will leave that exercise to you. So maybe you want to do it, and after you refine that, and check first also the number of the nodes, which is cannot exceed 1000, and if that's so, then you can run and you can get a better answer, which is reaching or converging to the theoretical answer, which is to be 22.96 megapascal. Okay, so that's all I want to show to you, and hopefully you can understand on how to use MECWAY to solve your problem for your mini project. Okay, thank you. Assalamualaikum.